Hi everyone, it's Coach Fred here, and today I'm going to be doing a short video on trigonometry. This is going to be video number one of a couple for the ACT. But I don't think there's any way to start really talking about trig without talking about the Pythagorean theorem. And so you should feel comfortable with the Pythagorean theorem, a squared plus b squared equals c squared. Now, if your teachers didn't spend a lot of time on Pythagorean triples, this is something that I would put some time in if I were you for the ACT. I see them all the time on these standardized tests, and so knowing them and not having to calculate the Pythagorean theorem every time is really helpful. So some of the common triples are 3, 4, 5, and then any multiple of 3, 4, 5. So like 6, 8, 10, 9, 12, 15. And then 5, 12, 13, 7, 24, 25, 9, 40, 41. So these all come as integer values or side lengths of the triangle, but the largest side has to be the hypotenuse. So for example, if I gave you 3 and 5 on the sides of a triangle, this would not be 4. Because the hypotenuse always has to be the longest side. So you got to be really careful with these Pythagorean triples. There's a lot to remember here, though, isn't there? But one thing I want to point out on the odd, when the smallest number's odd, when the smallest leg is odd, the other two values are consecutive integers. And actually, the really interesting thing about it is if you square the first number, so 3 squared is 9, these two integers are going to add to that square. 5 squared is 25. Look, 12 and 13 add to that square. 7 squared is 49. 24 and 25 add to 49. 9 squared is 81. 40 and 41 add to 81. It's a nice way to help yourself remember these triples. But when I tell you they come up in lots of questions, it's really helpful for us to put some time into memorizing them. But you might be saying, Coach Fred, what about the evens? Well, the one that comes up all the time is 8, 15, 17. So I'm gonna give you that one as well. But that is the smallest leg is even. The others are consecutive, not consecutive integers, but like these are consecutive odd integers in this case. But this one does come up a lot, so it's definitely helpful to know. All right, so let's move on. Let's talk about why we're here, trigonometry. So in geometry, you learned about SOHCAHTOA. SOHCAHTOA is just a mnemonic. SOHCAHTOA isn't mathy other than to help me remember how to solve or find ratios to right triangles, okay? So it's very important that you understand that this is just a mnemonic to help you understand the ratio. So the ratio is the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and the tangent is the opposite over the adjacent. But I find that students forget the most important part. It's not just sine opposite over adjacent. It's sine of the angle. So in this case, x is equal to the opposite over the hypotenuse. So in this case, sine of x would be 3 over 5. So sine of the angle equals 3 over 5, and that's a ratio. That's just a ratio, and that ratio can help me find the angle. Okay, cosine. Cosine of the angle would be equal to the adjacent over the hypotenuse. So in this case, cosine of x would be 4 over 5. Okay, and then tangent. Tangent of the angle would be equal to 3 over 4, opposite over adjacent. Now, that is just the ratio. If I want to find the angle, then I use the ratio along with the inverse function to solve for the angle. So for example, if I wanted to find the angle using sine x, I would have to do inverse sine of 3/5. I'd have to undo the operation of sine. On your calculator, it looks like a -1. I put in inverse sine of 1. Inverse sine of 3 over 5, and I would get 36.9 degrees. Now, one thing I want to point out now, algebra 2, I called it inverse sine. It also could be written as arc sine 3/5. Now, I didn't have to use sine. I could have used cosine. I could have done inverse cosine of 4/5 to get the angle, or I could have used inverse tangent or arctangent of the angle. But I just wanted to make sure that you understood that when you're trying to find the ratio, it's one thing. When you're trying to find the angle, you have to use the inverse function. In my class, I always, we came up with the mnemonic NAUI. Need angle, use inverse. Need angle, use inverse. All right, so let's put that to work in an ACT type question. Which of the following trig equations is valid for the side measurements x inches, diagonal measurement y inches, and angle measurement w in the rectangle below? So it's a rectangle, so we know it has a right angle in every corner. And so I can see that I'm working with this triangle on the right of the rectangle, including the diagonal of the rectangle. So I always look at where W is, and in reference to W, I have its opposite leg and the hypotenuse. So opposite hypotenuse is so. So sine of the angle, so sine W equals x over y. I look at my answers, I can see the sine W equals x over y. All right, so that's one way, basics on trig. You might be asked to solve a problem with trig where they don't give you any triangle, they just give you some words. So these are angle of elevation and depression questions. Suppose you're a lifeguard looking down at a swimmer in a swimming pool. Your line of sight forms a 55-degree angle of depression. You are 10 feet up in your seat. How far is the swimmer from the base of your lifeguard stand? Well, we have to understand angle of depression and angle of elevation to do this. An angle of depression always goes from a horizontal downward, whereas an angle of elevation goes from a horizontal upward. So an angle of depression, if I were to make this my triangle, an angle of depression is actually not in my triangle. So I have to use the idea of alternate interior angles to get an angle in the triangle, because those angles that form the Z would be equal. So in this, if I'm going to do this problem, I have to draw a really good picture. So you're a lifeguard and you're here. You're on a stand 10 feet high. You see a swimmer, okay? You see a swimmer that forms a line of sight, 55-degree angle of depression. So from here, from your horizontal, from your eyes going straight out, down to the swimmer, you see is a 55-degree angle of elevation. How far is the swimmer? So here's my swimmer from the base of your lifeguard stand. So it's asking for this length right here. All right, so I do have a right triangle, but I do have to figure out what angle I need an angle in the triangle to do this. So the angle of depression equals the angle of elevation, so 55 degrees. Then I write my equation. Based on that angle, 55, I have the opposite. I need the adjacent, opposite adjacent, so TOA. So tangent of the angle, in this case tan 55, equals 10 over x. All right, how do I solve this? Well, I clear fractions, multiply both sides by x. And I get x tan 55 equals 10, and then I divide by tan 55. Now, the one thing I want you to know is that this now is calculator ready. Oftentimes, I've noticed on the ACT that they actually don't ask you to calculate that out. They'll say, which equation could you use to find the length from the base to the lifeguard stand? So this is actually calculator ready, and this is what they're looking for, 10 over tan 55. Now, they could ask you to calculate that out, so you do 10 divided by tan 55, making sure you're in degree mode, and that would give you 7.002. So I'm just going to say 7. So in this case, 7 feet. So that person's about 7 feet from the base of the lifeguard stand. All right, let's look at an example where they did ask for calculator ready, and you just have to know that. Alex props up a ladder against a wall. The ladder makes an angle of 23 degrees from the ground. If the ladder is 10 feet long, what is the expression for finding the distance the foot of the ladder is from the wall? Again, this is one of those trig problems. We have to draw a good picture. So here's my building. Here's my wall. I have a ladder leaning against it. The ladder is 10 feet long, and the angle with the ground that that ladder makes is 23 degrees. So right here. It wants to know, it wants to find the distance the foot of the ladder is from the wall. So the foot of the ladder is right here. From the wall, it would be here, so I'm looking for X. All right, now if I look at all those answers, it can get really confusing. So try to stay away from them in this case. So I try to just write my trig function and go from there. So I have the adjacent in reference to 23, and I have the hypotenuse. Or I want the adjacent, I have the hypotenuse. Adjacent hypotenuse would give me cosine. So again, cosine of the angle equals X over 10. Okay, so I automatically knew that D and E were out. I knew I needed a 23. In this case, I was using cosine, so I could really get rid of sine and tangent. But this is asking for one more step. It's asking for calculator ready. What is the expression for finding the distance? So I'd multiply both sides by 10, and there you can see as your answer 10 cosine 23. All right, guys, that's it for today. This is just video number 1 on trig. And take a look at video 2 and 3 when you get a chance. And if you like it, I'd love for you to give me the thumbs up on YouTube. Thanks.